Alright, we're now going to look at the conic section called circles. This is actually my favorite one. I think I found it the easiest last semester, and I think the kids last semester also found it the most enjoyable and the easiest. So I'm reading off the slides again, so once again, you really should be looking at the slides and the notes that I posted on the task stream. But a circle is just a set of all points in a plane that are the same distance from the center. So all these points that are on my line of the circle are all the same distance from my center point. This segment right here is called the radius, and any segment whose endpoints are the center and a point on the circle are my radius. Okay? So, my center, we're also going to refer to him as h, k, just like my vertex that I use in parabolas. And my radius will be r. Okay? The distance formula and the midpoint formula that are in your notes on your page 9 in the J-term packet, those are also on the formula sheet that I gave you in class, that quality core formula sheet that you are expected to keep and not lose. But the other main important formula that you need to know for circles looks a little like this. X minus h. Remember, x and h are always paired together because h is the x coordinate of my center, squared, plus we'll have y minus k squared equals your radius squared. This is the part that a lot of kids forget. It's always set equal to the radius squared. It's not just set equal to the radius, it's also squared. So you'll need to find the radius, you'll have to take the square root. Another way that this formula could show up is simply in its general standard form of ax squared plus by squared plus cx plus dx plus e plus f. It'll be that standard general form that you kind of seen in quadratics, and we'll do an example together. But this is why I said that completing the square this entire past unit has been so important. We're going to use it to help us graph circles. Alright, we're now going to look at graphing circles. This is the very first example, it's one of the easier ones. Whenever you see an example and there's no x by itself or no y by itself, that means that your center is automatically at the origin, automatically at 0, 0. Okay, because I could essentially rewrite this as x minus 0 squared plus y minus 0 squared. And it wouldn't change anything. Now, I have to figure out, this is always set equal to the radius squared, so what's really being squared to get me 16? Well, 4 squared is 16. So my radius is 4. Alright, now I got to graph this. So my very first thing I need to do to graph a circle is I need to plot the point at the center. My center is at 0, 0. So I plot my point. Next, the easiest way to graph a circle is by drawing 4 basic radii, or radius plural. I'm going to go to the right by 4 units, plot a point. I'm going to go up 4 units, plot a point. I'm going to go left 4 units, plot a point, down 4 units, plot a point. Now comes the fun part. All you need to do are connect your dots. Your circles won't look like perfect circles, and that's okay, but it's close enough. Alright, we're now going to look at graphing another circle when it's not having a center at the origin. Now, in this example, my center here, I'm given my h and my k. It's important to look at the signs, because this is minus 3, my h is 3, and this is plus 2, so my k is negative 2. Now the radius is always set equal to the radius squared, and the square root of 9 is 3. So now I go to graph this. My center is at 3, negative 2. So now the strategy is that for the radius, I'm going to go out to the right 3, 1, 2, 3. I'm going to go up 3. I'm going to go to the left 3. And I'm going to go down 3. And now I'm just going to connect my dots. Once again, it does not have to be the most beautiful circle you've ever seen. Some property that I'd like to point out about this circle is the fact that it is tangent to the y-axis. What this means, the y-axis is my up-down part of my Cartesian plane. It is touching the y-axis in exactly 1 point. You're going to come across a question where it's tangent to the y-axis, and you need to visualize that it's only touching the y-axis in 1 point. All right, we're going to look at one more example of circles when we're given the circle in non-center radius form. It's given in general form like this. So the first thing that I want to do is pair the variables together. So I'm going to bring the x squared and the negative 4x next to each other, and the y's next to each other. And I'm also going to put the constant on the other side by adding in this case. The next thing I'm going to do, the thing I've been warning about, we are going to complete the square twice. Alright, so once for the x's and once for the y's. So I'm going to put parentheses around them. And I didn't change the signs or anything here in the y. I can use plus and plus. Nothing changed. And now if there were constants in front of the x squared and the y squared, the first thing you would need to do is divide every single term by this constant, and it'll always be the same. Something for you to notice later on. Alright, so now, the completed square of this, half of my value 2. Half of my value of 8 is 4. And now, I'm adding. That was half of my 4, and I'm squaring him, so that will be 4. That was half of my 8, and now I'm squaring him, so 4 squared is 16. So now, 5 plus 4 is 9, and 9 plus 16 is 25. So, by completing the square twice, I've now found my center. My center is going to be 2, negative 4. My radius is going to be 5, because 5 squared is 25. Now I'm going to plot my points. So, first I go for my center. My center is at 2, negative 4. And now I'm going to go out 5 spaces in each direction. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. And now I'm going to connect my dots. The bigger your radius gets, the harder it is for your circle to be connected. But there you have it.